everyone. In this video, we will explore the concept of arrays in data structures. Let's start by understanding what is data structure. Data structure can be defined as the group of data elements which provide an efficient way of storing and organizing data in the computer so that it can be used efficiently. Some examples of data structures are array, linked list, stack, queues. Data structures are widely used in almost every aspect of computer science. For the example, operating system, compiler design, artificial intelligence, and many more. Data structure can be subdivided into two major types: linear data structured and nonlinear data structured. Linear data structured. A data structure is said to be linear if its elements combine to form any specific order. For the example, array and linked list. If data items are arranged in an orderly manner where the elements are attached adjacently. Nonlinear data structure. This structure mainly represents data with a hierarchical relationship between different elements. For the example, trees and graphs. It arranges the data in a sorted order and there exists a relationship between the data elements. Let's start by understanding what variables are. A variable is essentially a placeholder or a structure used to store a basic unit of data. For the example, an integer variable stores a single integer value, while a float variable stores a single float value. However, if we need to store multiple pieces of data of the same type, like the marks of 10 students, this is where array come in, and we will discuss that in details. Array is a container which can hold a fixed number of items, and these items should be of the same type. Most of the data structures make use of arrays to implement their algorithms. Following are the important terms to understand the concept of array. Element. Each item stored in an array is called an element. Index. Each location of an element is an array has a numerical index which is used to identify the element. Why use arrays? Imagine you need to store and print the marks of 20 students. You could declare 20 individual variables, but that approach becomes impractical when aligned with larger datasets, such as 100, 500, or even 10,000 students. Array provide an efficient solution by allowing us to store multiple data elements of the same type in a single structure, making it easier to manage and manipulate large amount of data. Arrays have several important properties that you should be aware of. First, arrays are finite, meaning they contain a limited number of elements. Second, arrays are ordered, with elements stored in continuous memory locations. Finally, arrays are homogeneous. It means all elements in an array are of the same data type. These properties make arrays a powerful tool for handling collection of data. Before we can use an array in our program, it must be declared. Declaring an array involves specifying the data type, the name of the array, and its size. For the example, in Java, you can declare an array with like this, where int is the data type, num is the name of the array, and 10 indicate that the array can be held up to 10 integer values. Arrays can be declared in various ways in different languages. For illustration, let's take Java array declaration. First, you might have a simple integer variable like int a equal 15, which stores a single integer value. However, if you need to store multiple integers, you can use an array. For the example, in second example, it creates an array named num that holds 3 integer values 11, 10 and 20. Similarly, you can have a character variable like char my letter equal z. Array can be declared in different way depending on the programming language. But in Java, one common way to declare an array is by specifying the data type, followed by square brackets and the array name. For instance, declares an array called num that can hold 10 integers values. This array is initialized with the capacity to store 10 integers, although the actual values would need to be added later. Array supports a variety of basic operations that are essential in data structure. First one is traverse. It means print or visit all the array elements one by one. Second one is insertion. It means adds an element at the given index or position. Third one is deletion. Deletes an element at the given index or position. Search. Search an element using the given index or by the value. Update. Updates an element at the given index. Merging. Merging two arrays. Sorting. Sorting an array is ascending or descending order. Let's talk about one by one. Traversing an array means ascending each and every element of the array for a specific purpose. Traversing the array element of an array can include printing every element, counting the total number of elements, or let's see how to insert an element at a specific position. First, get the element to be inserted, say x. Then get the position at which this element is to be inserted, say pos. Create a new array with the size 1 greater than the previous size. Copy all the elements from previous array into the new array till the position pos. Insert the element text at the position pos. Insert the reset of the elements from the previous array into the new array after the pos. Searching an element in an array. Step 1. Traverse the array. Step 2. Match the key element with array element. Step 3. If key element is found, return the index position of the array element. Step 4. If key element is not found, return -1. Deleting an element from an array involves removing the specified item, then shifting the subsequent element left to fill the gap. The array size remained the same, but the last element become redundant since array have a fixed size. Merging two arrays involves combining the elements of both arrays into a single new array. The new array contains all elements from the first array followed by all elements from the second array, previous their original order. I think you got a clear idea about arrays in data structure. See you guys in next video. Thank you for watching. Bye.